Here's the first 5-minute video on forces. This is one of the topics that's going to come up in your Physics Paper 2 paper, and this is just covering some basics. First thing we're going to talk about is the difference between a scalar and a vector quantity. Quantity just being a word for number. So think of a scalar quantity, a scalar number. That is something that only has magnitude, and magnitude is just a scientific word for size. So think, for example, speed, 70 miles per hour. That's just a number. Distance, 5 meters. Again, that's just a number. Even number of cars in a car park, that is just a number. So anything that's just a number is a scalar quantity. This is in direct contrast to vector quantities. Vector quantities are quantities that have a number that has magnitude, a size, and an associated direction. And an example here is velocity. So when I say that the car is travelling with a velocity of 70 miles per hour towards Exeter, that must be a velocity because it's got a magnitude, 70 miles per hour, and an associated direction, which is towards Exeter. Forces are always vector quantities too. So the good example that we're going to go through is weight. Weight is an example of a force because, take me for example, I'm 750 newtons, that's my weight. So the magnitude of my weight is 750 newtons, and the direction of my weight, well, it's always pointing towards the centre of the earth, downwards. So my weight, 750 newtons, is an example of a force. And it's what we call a non-contact force. Now that's because I have a weight of 750 newtons, regardless of whether I'm touching the ground or not. So non-contact forces arise whether objects are physically touching or not. So other examples of non-contact forces include magnetism or electrostatic forces. This is in direct contrast to just contact forces. A contact force only occurs when two objects are in contact with each other. So think, for example, when you produce tension in a rope, that's because you are pulling on a rope. There is a physical, you are physically touching that rope. Think of friction. So I'm building up friction in my hands right now, and in order to cause that friction, my hands must be touching. So weight, if we continue with weight, weight is the force acting on an object due to gravity, due to an object being within the Earth's gravitational field. And we've got a lovely equation for that, and you need to remember this one. So weight equals mass times gravity. Now in the exam, a little tip here is that gravity will be given to you as 9.8 newtons per kilogram. So when that's given to you, you're going to have to use this equation. Here we've got an example. Here's the Earth, look, and there's a red box weighing which has a mass of 10 kilograms. Remember, weight and mass are not the same thing. So to find its weight, this red box's weight, I'm going to do mass times gravity. So weight equals 10 kilograms, times gravity, 9.8, and the weight of that box, which is 10 kilograms, is 98 newtons. Let's go back to forces up here. Now, a resultant force acting on an object causes acceleration. This is really important. So when you're asked to calculate the resultant force on an object, you need to ensure that if there is a resultant force, it causes acceleration. It doesn't just move, it accelerates. If the resultant force is 0, the object is either stationary or it's moving at a constant velocity. So have a look here. Here we've got a pink ball, and that pink ball is falling. I know this because the weight acting downwards is 10 newtons. And the drag force acting upwards, the air resistance, is 8 newtons. So if I'm going to draw the resultant force on this pink ball, it would be like this. 10 minus 8 is 2 newtons. So the resultant force acting on this ball is 2 newtons downwards. And the way I'd summarise that is as follows. The resultant force of 2 newtons acting on the pink ball will cause the pink ball to accelerate downwards. Note I've used the words accelerate and not move. Finally, we can add an equation into the mix here. Okay, so here we've got a cart, and that cart has a mass of 5 kilograms. And this cart has a resultant force acting on it of 20 newtons. So I can use this equation here, which is resultant force equals mass times acceleration. It's also called Newton's second law of motion. If that comes up, you can write that equation down. So if F equals m times a, resultant force equals mass times acceleration, rearranging that using that triangle, so cover up the a is F divided by m, so the acceleration is 20 newtons divided by the 5 kilogram mass, and that works out 20 divided by 5 is 4 meters per second squared. So they are just some of the real basics that you need to know before your paper 2 equation to do with forces. Paper 2 paper to do with forces.